My name is Joey. I am a tutor at the Arizona State University Economics Tutoring Center, and I'm going to show you how to derive an OLS estimator for beta 1 hat. So this will be a two-part video. Part 1, which is what we have right here, will be deriving a beta not hat. And so this function will be able to help you derive beta 1 in the next video. So here we have our population regression function, which is y equals beta naught plus b1x plus u. So the first thing we're going to do is we're going to use one of our rules over here, which is an assumption that the expected value of u is equal to 0. So the expected value of u is equal to 0. So we're going to need to find a value for u, and the way to do this is just to subtract everything from the right side and just find a value for u. So u is going to equal y minus beta naught minus beta 1 x. So then what we're going to do is just plug in this function into our expected value. So the expected value of y minus beta naught minus beta 1 x is equal to 0. So in order to get rid of the expected value, what we'll do is just take the summation of our population function, and doing that is how we're going to come up with a sample function. So 1n times the summation of yi minus beta naught hat minus beta 1 hat xi. And as you know right here, our notation changes from our population function to our sample function. So this is actually how, when you're running a regression, this is tells you how you come up with your different estimates by taking your population, turning into a sample. So we will distribute this summation function to every single term in here. So we'll have 1n times the summation of yi minus 1n times the summation of beta naught hat minus 1n summation of beta 1 hat xi. So using our rules over here, we can find different ways to write this down so we don't have the whole 1 over n summation mess. So using rule number 2, we know that 1n times the summation of yi is just going to give us y bar. So this is just the mean of our dependent variable. So then minus, using rule number 3, we know that 1n times the summation of an estimate is just going to be our estimate, which is going to be beta naught hat. And then using rule number 4, we'll be able to go and get our beta 1 estimate times the mean of the values associated with the beta 1 estimate. And this is all equal to 0. So in order to isolate for beta naught hat, what we're just going to do is add beta naught hat to both sides, and we will get beta naught hat is going to equal the mean of y minus beta 1 hat and the mean of x. So our beta naught estimate is just going to equal y bar minus the estimate of beta 1 times the x bar. So we're going to use, the reason why we did all of this is so in part 2 of our next video, this equation is actually going to help us solve the estimate for beta 1 hat. So performing all of these steps and functions is part 1 in deriving your estimate for the beta 1 hat. If you need any more help in Econ 425, Econometrics, or any other econ classes, please come into the Economics Tutoring Center and watch part 2 of this video for the final part of OLS derivations.